set of equations, and if the equations contains more than 3 unknowns and more than 3 equations, in that case we are not in a position to solve these methods by ordinary methods. So that is, ordinary methods means simultaneously by manipulating equations, adding 2 equations and creating a new equation, and then equation is solved with respect to third and so on. Or we are unable to implement this Kramer's rules also. Kramer rule is applicable up to maximum 3 by 3 matrix. If your matrix is more than 3 by 3, it means that the 3 equations and 3 unknowns. If the unknowns in the equations are more than 3, then so it is not applicable, or it has a limitations. So if the equations, simultaneous equations, a problem contains more than 3 simultaneous equations and more than 3 unknowns, in such cases, so we have to apply some advanced numerical methods. Those numerical methods are Gauss elimination, Gauss Seidel, Gauss Jordan, matrix inversion, and Jacobi method, and Thomas algorithm. Likewise, there are n number of numerical methods were available. So by using these methods, you can solve the equations which contains more than 3 unknowns and more than 3 equations. So now one of the method, the most popular method, and this method belongs to direct method. So this is not belongs to iterative method. So this method, Gauss elimination method, is a direct method. You remember this point, underline this point. It is a direct method. So in Gauss elimination, so this method is named after a Carl Friedrich Gauss in 1777 to 1855. Although some special cases of these methods have been studied by some other Chinese scientists, and they have invented this method long back, so before 2000 years ago. And these method, or a Gauss elimination method, utilizes 3 elementary operations. So first operation, swapping of 2 rows, 2 or more rows. Here you can say swapping of 2 or more rows. So because this is written in context with the 2 to 3 rows. So if your system have a more than 2 or 3, so in that case, so you can swap these rows, and multiplying a row by a non-zero number for elimination. Just now we have seen, so for example, this is 2x plus 3y is equal to 10. This is one equation, and second equation is x plus 4y is equal to 6 or 7. So there are 2 equations. Suppose say if you want to eliminate this, so this second equation is multiplied by 2 and first equation is multiplied by 1. It means that it remains as it is, and then you change the sign. So this is 2x get cancelled, and this is how you will get the value of y, and then substitute the value of y in any one of the above equation, you will get x value. So this is the procedure adopted or proposed by this Gauss. And second, adding a multiple of one row to another row. So this is the example, adding of one row to the another row, and then you have to find x and y. So this is the general procedure initially proposed by this Gauss elimination for computing the values. And then a matrix can always be transformed into a upper triangular matrix. This is the second point. So first of all, you can swap 2 or more rows, multiply. So this is the one way sorry, we have to perform three kinds of operation on this. By performing these three kinds of operation, so you can convert this given set of simultaneous equation into a upper triangular matrix. So this is, you remember what is upper triangular matrix. So just I have a one figure, I will show you. Hmm? So it is not necessary always you have to convert into a upper triangular matrix. You can also convert this into a lower triangular matrix also. Hmm? But preferably, so many times it's a very easy for computation. So therefore, upper triangular matrix is preferred in number of cases. So this is the given matrix, initial matrix. So this matrix is converted into upper triangular matrix. So it means that upper triangular matrix contains zero element below the diagonal elements. So these are the diagonal elements. So dashed line, and here 0 0 0. So these three are 0. So such matrix is called a upper triangular matrix. Upper triangular matrix. So you remember this. Hmm? So these are all highlights. What is upper triangular method, what methods they are following. Hmm? And to create this upper triangular matrix, what method is used? This is the forward elimination method is used to obtain upper triangular matrix. And similarly, here itself I will tell you, so what is the lower triangular matrix? In case of a lower triangular matrix, say diagonal matrix, I will write A11, A12, A13, sorry, A22, A33. So A11, this is 0, so this is 0, and this is 0. It has A21, A31, sorry, here it is A32. So the below, above the diagonal element, the element which are present above the diagonal of this matrix are 0. So such matrix is called lower triangular matrix. Lower triangular matrix. So this is the difference between lower triangular matrix and upper triangular matrix. To obtain this lower triangular matrix, similar to obtain this upper triangular matrix, we are using forward elimination. To obtain this, so we have to apply backward elimination. Backward elimination. So either of these two you can use any one. So this is opposite. So here to get the upper triangular matrix, we have to apply forward elimination. To get the lower triangular matrix element, so we have to apply back elimination procedure. So here especially referred upper triangular matrix because it is popularly used, and in many cases, so we are using this. Now next, once you know, so you convert this matrix, upper triangular matrix, into equation form, and in you solve these equations for unknowns, so you will get the solution. How we have to do? So we have to go back, because so why it is called a back substitution means, see here, you will see here, so that I am going to solve with the help of numerical. So here there is only one unknown, ax3 is equal to 0, means x3 is equal to b3 double dash 3 upon a double dash 3. So you will get this x3. Once you know x3, so here it contains x2 and x3 is equal to b dash 2. Now here already we know the x3, only unknown is x2. See here, you write the equation in terms of x2, x3 is known, so this x3 value is substituted here, and all are now constants, so you will get the value of x2. Similarly, to compute x1, so already we have computed x3 here, so that value is used, and x2 value here, and you will get. So back substitution, from below we are moving up, upward side, that's why it is called a back substitution. Similarly, So if you are applying a back elimination, so you use your forward substitution method. Forward substitution method. So in case of a back substitution method, you will get x3 first. In a forward elimination method, you will get x1 value first and then x2 and later on x3. So like this. So this is the procedure adopted in Gauss elimination. So in a nutshell, what we have to do. So a set of equation given. So those equations, first of all, we have to write in the matrix form, and then you apply forward elimination procedure. So in forward elimination procedure, we are converting this existing matrix into upper triangular matrix, and then we are applying a back substitution method to find the values of unknowns. So those unknowns are, so this is x3, x2, x1. So this is the procedure adopted in Gauss elimination.